Hello students, welcome to lecture 2 of alcohols, phenols, ethers. Uh, Here, let's learn the preparations of the alcohol. Preparations of alcohol. You can watch this video at a 1.25 speed also. You can just increase this speed if I'm very slow. So, preparation of the alcohol first is from hello alkene. Means alkyl halide, or I will write alkyl halide. This is the same reaction what we studied in the first chapter, that is haloalkanes, haloarine. That is, we learned under SN1 and SN2, right? Under this reaction, we learned SN1 and SN2. Same reaction. Here we are learning this as a preparation method. There we learn this reaction as a property, right? Chemical uh, property of the alkyl halide, how it reacts with the nucleophile. So reaction is very simple. First, I'll write a general reaction, R X, and this is NaOH. Very important writing this aqueous. AQ sometime it is written, and this gives you ROH plus NaX. This is a general reaction. This is what alkyl halide. This is alkyl halide. This is a source of nucleophile. This is a source of nucleophile. That is OH minus. OH minus is a nucleophile. This is alcohol which is formed, and this is a salt which you are getting. What is X over here? X is a halogen. Halogen means fluorine, chlorine, bromine, iodine. Fluorine, not fluorine, but we use chlorine, bromine, and iodine. So this is the thing. The meaning of this, if you take a methyl alcohol, if you take a methyl halide or a methyl chloro chloromethane, will take this. This is chloromethane. And if you react this with NaOH, the compound, what you are going to get is CH3OH plus NaCl. This is what? This is methanol. This is chloromethane, right? One carbon system. This is sodium hydroxide. Important, you write this aqueous hydroxide. And this is sodium chloride, which is a salt. This was the thing about the reaction. But what is the mechanism? Let's understand the mechanism. See, slowly, we have to keep this attitude of learning a mechanism also. What is the mechanism happening over here? So I'll go to the next page, that is over here. Let's talk about the mechanism. I'll take the example. What I'll do here, we'll go back over here. I can take a better example this way. Like R group could be anything. No, I'll take this. If it is a ethyl chloride, if it is a ethyl chloride, and this is NaOH, what would be a product? Product would be this way. Product is ethanol or ethyl alcohol. This is chloroethane. This is sodium hydroxide, right? So here, if I take this example, let's write the mechanism for this. So here, this is CH3, CH2, Cl. Step 1. Step 1 is the attack of the nucleophile. Step one, step one is attack of nucleophile. Now, what is a nucleophile over here? I told you that NaOH, which is used over here, understand a meaning of every reagent. It will be very easy for you to remember. This is a source of OH minus, source of OH minus. OH minus is a nucleophile. What is the meaning of nucleophile? Nucleophile is a definition by definition. See, slowly, you should be adapting to these definitions. That is, what is nucleophile? What is electrophile? So, nucleophile, I'll write the definition over here. Nucleophile is electron-rich species. Electron-rich species. So, minus means electron-rich. So, this is the OH minus, right? This is OH minus. Now the thing is that this OH minus is going to donate OH minus over here. It is going to donate electron, or I can say that it is going to attack on this carbon. The reason is that this is partially positive. This carbon is partially positive, and this is not so positive. This carbon is not so positive. See, always keep one thing in mind, that negative attacks the positive, right? Negative attacks the positive. And how I decided that this is positive? Because this is connected to a electronegative element. This is connected to electronegative element. Chlorine is electronegative. Now coming back to the base, that what is the meaning of electronegativity? Electronegativity. By definition, electronegativity is a tendency of an atom or an right atom or element, one and same tendency of an atom or element to attract shared pair of electron towards itself. This is what is the meaning of the electronegativity is. Now, which are the electronegative elements? If you ask me which are the electronegative elements, just make a note that all the halides, that is fluorine, chlorine, bromine, iodine, these are electronegative. Then nitrogen, phosphorus, nitrogen, sulfur, oxygen, they fall into the category of the electronegativity. Means they have the tendency to pull the electron. Means one bond is, means there are two electron, no? So this electron which is there, it will be more in the side of the chlorine. This electron of the carbon will be more in the side of the chlorine. Then what will happen? It will develop a partial positive charge, isn't it? So obviously this is going to go and attack on a carbon which is this carbon, and it is not going to attack on this, right? So here, what is the meaning of attack? OH minus is going to form a new bond over here with the carbon. Means already carbon is having a four bond, and what is the thing happening? That this OH is going to form a new bond, means carbon is going to have a fifth bond, no? But it's not possible to have a five bonds on a carbon, right? So one bond should break. So which is the weakest bond? Okay, one bond should break over here, right? I'll just write this in open chain structure, that these are the two hydrogens, right? One bond should break. So which bond will break? We have to understand which bond will break. Which bond will break, right? So weakest bond. Answer is weakest bond. Answer is weakest bond is going to break. Weakest bond is going to break. Bond will break. Now, which is the weakest bond? It is the longest bond. Longest bond will break easily. Longest bond will break easily. Uh, as longer sticks are easy to break compared to the shorter one, it is longer bonds are easy to break. Among this, carbon chlorine is the longest bond. Who decides the bond length? Atomic radius. So atomic radius of the chlorine and a carbon, or atomic radius of the chlorine is higher among this. Means if I want to say a carbon chlorine bond, then it is the longest bond because of the atomic radius of the chlorine. Here atomic radius of the hydrogen is smaller, so these bonds are not going to break, nor this, the carbon carbon bond is also smaller. So this is the bond which is going to break, right? So what you get? You get a compound CH3 CH2 OH, and this is gone as a electron. It has taken the electron, right, of a carbon only while breaking. So it will be forming what? Cl minus. That will combine with a Na plus of this. That will combine with a Na plus of this to form what? NaCl. So this is your product, and this is the whole mechanism. How to identify this reaction? Okay, so always remember that there may be a possibility. It could be written this way: CH3 CH2, CH2OH. And if they have given a base like potassium hydroxide, and instead of aqueous, it is an alcoholic medium, then understand that OH minus is going to act like a base. Base means it is going to abstract a H plus. Or it is going to extract, elimination is going to take place over here. So just take a care over here how to identify this. Mostly if it is a substitution reaction from the alcohol, it will be written aqueous. And if it is alcoholic, we'll do this further. But I'll just tell you at this point, it is going to give you alkene this way because minus water you are going to remove from this. One OH and one hydrogen from here. So this is going to give you alkene. So just this is the care you have to take, whether it is a alcoholic or aqueous. Once you know this, so you understand that it is a substitution reaction, nucleophilic substitution reaction. So here this reaction falls under the category of nucleophilic substitution because nucleophile is getting substitution reaction. Next method is preparation of the alcohol. Next method is preparation of the alcohol. Preparation. That was the first method, preparation of alcohol from alkene. What is the meaning of alkene? Alkene is the hydrocarbon. They are the hydrocarbon having at least one double bond. Double bond. That is alkene. So here, what is the method? It is a hydration. Okay. The method is hydration of the alkene. Here we are going to learn two reaction. One is hydration of the alkene. Hydration of alkene. What is the meaning of hydration? What is the meaning of this? What is the meaning of hydration? Hydration is hydration is addition of water. Addition of water. That is what the hydration. So we are going to do the hydration of the alkene means addition of water to the alkene. And it is what? It is a addition reaction. It is a addition reaction means double bond will be there. It will be converted to single bond addition reaction. This comes under the category of addition reaction. So hydration of the alkene, there are two reactions which we are going to learn. One is acid catalyzed hydration, another is hydroboration oxidation. Okay, these are the two methods of addition of water to the alkene we are going to do. Let's do this in detail. So first I'll discuss about the acid catalyzed hydration. First I'll discuss about acid catalyzed hydration. Hydration means addition of the water and acid is added to speed up the reaction. Means this is the alkene. We'll take the alkene CH3, CH double bond CH2 and you add a water. The compound what you are going to get is this CH3, CH, OH and CH2H means this is the compound means CH2H means what? This could be also written as just CH3, right? So this is the compound what you are going to get over here. This is a secondary alcohol. This is secondary alcohol and name of this alcohol is a propane to all. This is the alcohol. Now, what happens? This reaction follows the Markovnikov's rule. It follows acid is there. Here there is a acid. Like here, addition is according to the Markovnikov's rule. What does the Markovnikov's rule? Actually, Markovnikov's rule it was for the HBr. HBr adding to the alkene. Okay, Markovnikov's rule. You get a Markovnikov's product. You get a Markovnikov's product over here. What is the meaning of this? Negative part of the adding species, negative part of the adding species goes to the carbon having less number of hydrogen in carbon-carbon double bond, right? This is what the Markovnikov's rule is saying. So, what is the negative part? If you break this water, it has a two parts. One is OH minus and the other is H plus. This is negative part, this is positive part. So this will go to the carbon which has less number of hydrogen in the carbon-carbon double bond. So it is going over here, means we are getting a OH and hydrogen is going over here. Now see the mechanism. Let's go into the mechanism of this. Let's go into the mechanism of this. Here there is a H plus. Here there is a H plus, right? I told you one thing is very common. Understand that it is attack is from or donation of the electron is from electron rich to electron deficient, right? Here this pi bond you can understand pi bond, one of the pi bond is a electron rich, pi bond is electron rich, pi bond is electron or this won't be correct to say this way, a compounds having a carbon connected to a double bond means pi bond is considered electron rich means the electron can donate. So this bond electron will be donated over here either this way or the other possibility that it will be donated this way. Let's say this is A and this is B, right? So we have to understand bond is going to break in two ways over here. One, if it is via A, if it is this way, or let's do B first. Let's do B first. If it is via B, then CH3, who will get the hydrogen? This carbon is going to get the hydrogen. So it is instead of CH, it will become CH2. And who will lose the electron in that case? This carbon is going to lose the electron in this case. So this is CH2 plus. And if it is going via, if it is going via A, if it is going via A, then it is this bond is going to break and this will gain a hydrogen and this is going to have a carbocation. This is going to have a carbocation over here. And this is the thing. Now this is primary carbocation and this is secondary carbocation, right? So what will happen? The OH minus later, this will be forming a more compound. This will be a major intermediate. This is major intermediate. Lot of the molecule will be going in this direction. Lot of the molecule means what? You must be thinking only one molecule are there. How some are going in this? See, it is a, if I say that water molecule, just giving you example of the water. Like this is a glass of water. This is water. Is it that there is only one molecule of the water? No, there are very large number of the water molecules. It is that way. So if this is a propene, then there are very large number of this. So OH minus is going to attack on this, right? And your major product is going to be this way. CH3, CH, OH, and a CH3. Getting? So this is the mechanism for the this reaction. Okay, so we should also know the stability of the carbocation. Okay, for basics, you can also refer my other videos which are there. I have given those videos in the description in under GOC section. So stability of the carbocation is this way. Understand? Stability of carbocation is this way. Tertiary is more stable, then secondary, and least stable is primary. You will, I have given the reasons over there. You can just know that. You learn everything about the carbocation over there. So this is the thing. Now, whenever there is one more story, I'll go into the little more depth of this. Whenever there is a carbocation formation, understand this. Whenever there is formation of carbocation, there are three possibilities. There are three possibilities. There are three. As of now, I'll just make a note of two possibilities. There are two possibilities. There are actually three. We'll discuss two. There are two possibilities. Possibility. One is hydride shift, and the second is methyl shift. Why this happen? Why above things happen? Why above things happens means hydride shift or methyl shift? What is the reason? Answer is very simple. To increase the stability of carbocation. Carbocation means if it is a primary carbocation, then it will change to what? Secondary carbocation. If it is secondary, then it will change to tertiary carbocation only if there is a scope. Why it did not happen over here? Just imagine there is a carbocation. If it shifts over here, it will become primary, right? This was a minor product, right? So if this shifts over here, it become primary. So there is no hydride shift. I'll tell you how the hydride shifts happen. We'll take a other example. I'll take a different example for this. Um, Same acid catalyzed hydration we are going to do on this. If I show you this CH3, CH and CH2, I add H2O to this, and in the presence of acid, what is the product? Product would be not OH over here, OH is over here. Understand this. CH3, the OH is going to come over here. This is CH2 and this is CH3. This will be a product. Let's understand it through mechanism. Let's understand it through mechanism. Mechanisms are very simple. Don't get scared of mechanism. If you're not learning the mechanism for some of the reactions, then organic chemistry learning is very incomplete, It is just raw. So we just can't learn organic chemistry raw that way. It will not like what I can say is that you are not going to enjoy it. What is very important is enjoyment. You should enjoy the process. So this is the alkene. Just understand, right? There is a H plus. The possibility that bond can break this way and bond can break this way means hydrogen can come over here or hydrogen can come over here. So here what I do is I write two. Let's say this is A and this is B. I'll show you the most stable attack. I'll show you the most stable attack. And let's not do that. A and B. You have understood that. So most stable attack will be this way. Hydrogen going to this, right? So the compound what you are going to get is this. I'm just showing the one. Other one is a minor, no, less stable. So this is CH, CH3, and this is the carbocation which is formed over here. Now this is primary. This is a secondary carbocation, not primary. This is secondary carbocation. And this will do what? Hydride shift. This will do hydride shift. Hydride shift means what? This hydrogen which is there, it will shift over here. Sorry, this hydrogen which is there, this hydrogen will shift here. And positive charge will shift there, right? Means why this is happening? The stability of the carbocation is increasing by doing so. This will become CH2, means this hydrogen is coming over here. If this hydrogen was not there, the methyl would have shifted. Since there is a hydrogen, smaller one, it is shifting, and the positive charge is coming over here. So what is this? This is a tertiary carbocation, which is obviously more stable than that. Now the attack of the nucleophile is going to take place. It is going to attack over here, and the final product, what you are going to have is this. CH3, CH2, CH3, OH, right? Name, I'll write this is to be 2-methyl butane 2-ol. This is the whole mechanism. Next, let us learn about hydroboration oxidation. Next, we'll learn about same under that second category. I said first was acid catalyzed hydration for the alkene. Next is hydroboration oxidation. Hydroboration oxidation reaction is this. It is the same alkene. We'll take a alkene, asymmetrical alkene. See, there also asymmetrical alkene we had taken. This is alkene. And what we do, what reagents we add is 1 minute. Just give me a second. So this is the thing. The reagents what we are going to add is this. It is B2H6 or BH3. Here mechanism is not important. I'll tell you. This is these are the reagent B2H6 or this is what either on the reaction arrow this will be given BH3. The alcohol here also addition of the water, but here what you get is a reverse of that. CH2, CH2OH. It is also addition of water, but here you get a thing about this is that here we get anti-Markovnikov's product. Anti-Markovnikov's product means what? Not following the anti-Markovnikov's mechanism. Remember, I am just saying that anti-Markovnikov's product. This goes via different mechanism. Okay, so anti-Markovnikov's product means what? Negative part of the adding species, negative part of adding species goes to carbon, carbon, which is having more number of the hydrogen, more number of hydrogen, hydrogen in carbon-carbon double bond, right? So here, this is a more number of hydrogen. That is where the OH is going. And what alcohol is this? This is primary alcohol. What you get is a primary alcohol. So here, there is no formation in reaction mechanism. Understand this. In reaction mechanism, mechanism, there is no formation of carbocation, carbocation. So no hydride shift. Therefore, no hydride or methyl shift. So if you compare both acid catalyzed hydration, acid catalyzed hydration, and the second one is a hydroboration oxidation, hydroboration oxidation. It is this. Here, the product forms are product form. Major difference are tertiary or secondary alcohol. Okay. Here, only primary alcohol. In reaction mechanism, no, here no hydride shift. Here it is no hydride shift. Hydride or methyl shift. Okay, here there is there is formation of carbo. There is uh, or we can write there is a formation of there is hydride or methyl shift. There is hydride or methyl shift. Since there is formation of carbocation intermediate. Since there is no formation of no formation of carbocation. So that is the whole point. That is a major difference between a acid catalyzed hydration. That is a major difference between a acid catalyzed hydration and a hydroboration oxidation. And it is that simple. Thank you.